Welcome to the Edgevana Podcast, where we illuminate subjects in the IT infrastructure space. Get ready to hear some amazing insights from outstanding individuals that will change the way you think about IT. And now, here's your host, Mark Thiele.
Welcome to another edition of the Edgevana Podcast. Joining me today is Rick Braddy from Burst. Rick, thank you very much for joining the program. Give us a little background on yourself. What are you doing these days, and what's Burst doing?
Great to be with you, Mark.
Thanks.
Well, so we are we've been in the cloud for about 8 years. We were in the cloud before cloud was popular like it is today. And we sort of saw the future vision of where the cloud was going. And my wife always tells me that I'm always early, ahead of the market. So I guess we were way ahead in that case. But so we've been helping customers move hundreds of applications, usually business critical subscription-based SaaS apps for the most part, into the cloud, for 8 years. And what we're seeing now is a similar sort of thing happening where at the edge, it's like the opposite, right? Everybody wants to, the industry seems to go through these periods where we want to centralize and then we want to decentralize, right?
Yeah,
and it goes back and forth, right? Yep. So I think everything's been centralized. Now we want to decentralize again. And this time it's for the edge, which is fine. And, we've got customers driving us in that direction, and we're excited about it.
No, that's awesome. And obviously, we've shared enough messages recently for you to know, my interest and enthusiasm for all things edge. So I'm anxious to talk about that some more. Data, generically speaking, data and the cloud have been two huge areas of contention and opportunity, right? There's no doubt that being able to apply new tools and capabilities against your data is an incredible opportunity, but there's also the issue of ownership and potential longer term costs, because everything sounds good when you just call it at 0.02 cents a gigawatt or a gigabyte. Mm-hmm. But when you start actually adding in things like ingress and egress and redundancy and BigQuery or Athena on top of it, et cetera, all of a sudden, what seemed cheap can become really expensive. Talk a little bit about what you've seen over the last 8 years of traffic going in and out of the cloud. What are some of the reasons that customers made the decision to go? What are some of the reasons why they didn't? And maybe even what are some of the reasons why they decided to back out after they did go?
Yeah. Well, fortunately, we've seen most of our customers that have migrated their apps and data into the cloud have stuck around. I can think back maybe one or two that have backed off or maybe moved to a different cloud, but these tend to be pretty sticky. It's, data has gravity, as you know, so it's hard to deal with. And once you've gone through the migration process, which often involves, downtime and there's a certain amount of risk associated with any migration project, I think customers tend to want to leave things where they are. But over time, that data just sits there and nobody seems to want to delete anything. So it just sits there and accumulates. And that 2 cents a gig does sound inexpensive until it's 5 years later and it's not gigs, it's terabytes or hundreds of terabytes, and it really adds up. So you got to have some kind of data archival strategy, and the tools are there, but you have to make use of them, right? Things like Glacier on AWS, the cold storage.
No, I think they'll be critical. So thinking about edge and data. It's funny. I just wrote a blog about what is edge and where is it, and I'm calling it an economic thing. Talk to me a little bit about how you perceive edge from a data challenge standpoint.
Yeah, so I guess first it helps to define what we mean by edge. Every time we go through one of these hype cycles, everybody wants to define it and warp it their way, but we see edge as being those outlying places and locations in a business where there may have been there all along. Sometimes it's just remote offices, remote factories. That's now considered the edge, right? But then there's the IoT sensor world that's really the kind of the new frontier edge, with the wind turbines and the the ships, actually the ships out on the ocean and the vessels floating around, connecting back through satellite, that's edge to us and our customers. And yeah, the challenges are at the edge, at least today, there's not a lot of data storage usually, because you've been trying to centralize the data to make it more manageable, et cetera. And the problem you're really trying to solve at the edge is often the opposite, which is I want to reduce the latency and I want to keep more data at the edge and move more compute. So I view it as sort of a lightweight edge problem that we see today versus maybe more of a heavier edge that we want to move more compute and storage to the edge. But none of that comes free. Nothing's ever free in life, right? So there's trade-offs in which strategy I think you end up with.
Yeah, no, and I would agree with all of that. I mean, it's a big part of why I'm doing what I'm doing, and the talks and advice that I provide when somebody in the industry asks. So, if somebody had asked me, maybe even just 2 years ago, what was the single biggest driver for edge, I would have defaulted to latency. And I would argue that 99% of us that ever knew anything about edge at the time would have defaulted to latency. And I'd like to just and I've asked a few people this question, but I think the business that you're in, I think brings more value to the answer than some of the other folks I've talked to might have. And that's, if latency isn't the key driver, what is? And my supposition is that the data volume and growth at the edge is actually driving opportunity. Some of that opportunity is reduced latency, but reduced latency wasn't necessarily the original goal. Does that make sense?
It does. I think it depends on what problem the customer is trying to solve. We increasingly see autonomy. I think, autonomous operation, rather than having everything rolling back up through the centralized nervous system, to make decisions centrally. I think distributing decision-making and AI, machine learning, deep learning increasingly out to the edge makes more sense. And then trying to pull all that data in, like you said, with all the ingress and especially the egress charges. And we actually see, we think of things coming from the edge to the central nervous system or into the central cloud or data center, but we're seeing the opposite increasing. We're seeing there's already so much data in the clouds today that they're wanting to push that data out to the edge for configuration management and to manage the edge. Because I mean, like any kind of distributed system, one of the bigger problems is how do you manage all of it? Right. So that's a problem in and of itself.
Yeah, telemetry data is great, but delayed telemetry data is almost worthless. So that's a great point. You've mentioned a couple of times now lightweight versus heavyweight for edge. Give us a little bit more about what you're thinking there. Is that a design strategy, or is it a use case oriented focus, or is it some combination?
I think it's some combination. And when we look at like what the cloud vendors are doing with their edge strategies, you've got things like AWS Outpost or Azure Stack Edge, right? Yep. So I think there your central management system is really the cloud management consoles, right? And you're trying to push more compute and storage however much you need. With Outpost, of course, you get a whole rack. But with I think Azure Stack Edge, you can get it's a more granular set of choices. But I think there's a broader spectrum of edge options available, and it looks like all the vendors, the traditional data center suppliers, the Dells, the HPs, IBMs, et cetera, they're all realizing that the growth in the traditional data center is starting to decline. So where are they going to go, right? With their gear. So I think it's towards the edge where the data growth is going to continue to explode and drive those sales. Right?
I would agree with that. And you mentioned that like 50% of the data created right now is created at the edge. Do you see that balance continuing to shift towards edge over the coming years?
Well, that's what the analysts see. I think they probably have a much broader periscope than I do. So they certainly believe it. Gartner and the rest of them that we talk to definitely see the explosion of data at the edge, and driven, I think, largely by IoT sensor data. But I think as we learn what all can be done at the edge, because it's still early days, I think we're going to see more and more shift to the edge. And like many of these things, probably go through some cycles where we'll have fits and starts, and then eventually we'll settle into some kind of stable edge architectures at some point. So I still think it's early days, but there's some pretty interesting options out there already today.
Yeah, yeah, awesome. Well, you've hinted at some of the challenges already associated with managing a distributed environment from a central location, et cetera, and totally agree. Do you see? I know you guys are definitely focused on the data, but the data is everything, right? The data is what makes an application worth running. So there are latency concerns for, as an example, you might have latency between a serverless function and where it gets its data from, or where it pulls additional information or attaches to an API, because of how the workloads are distributed, because of the fact that they're microservices or functions as a service. How do you see the alternative to that, which is the ability to distribute data and manage for concerns around latency? Are we looking at kind of a common application level on top of a standard data collection methodology that is then still on a day-to-day basis a unique entity in each location? Or do you see them like a shared capability between locations at the edge? What are you, from some of your first customers relative to data at the edge? I'm always worried about over replicating and the cost associated with it, the network impact associated with that, not replicating enough, and then having to worry about latency or failure issues. So I know I've offered a giant question there, but give me whatever you think you can.
Yeah. I think what we see, at least in the early phases with what we're doing at the edge, we see that the edge has actually been around for a long time, these locations, right? So they've grown up incrementally, like most things in IT and in business over time. So you don't even have the same factory equipment at every factory, right? You have everything evolved from the first factory to the 10th factory, and by the 10th time you may have completely switched many of the vendors out, but you still have to support all the old stuff too, the entire spectrum of what you have at the edge, whatever edge is. And so I don't see the symmetrical aspects of the data. The data seems oftentimes very unique for every edge location. Now, maybe when you're putting in new systems, you can control that better, right? But I just, in terms of retrofitting all the existing systems, which is where we see a lot of the growth. As an example, we're dealing with tens of thousands of ships out on the ocean, that probably were built over decades, right? So you've got engines and systems on those ships that are vastly different depending upon when they were built, who built them, and so on. So so I think we see a pretty diverse set of data. And so one of the challenges there is how do you manage that and centralize the data the ports of it you want in the cloud. And then we see the use of object storage is helpful for that in the cloud, for example. But we also see latency is not just an issue at the edge; it's an issue between the edge and back to the central data center or the cloud, because many times the edge is actually in a remote location. As an example, you might have a factory that was built outside Mexico City. Maybe the connectivity is not really what we're accustomed to with 1 gigabit networking, right? You may, or if you've got folks out on offshore rigs or ships or what have you, they're mobile, then you're dealing with radio links or satellite links, other forms of high latency, packet lossy types of networks. So, there's a number of different challenges depending upon what all the edge topology involves ultimately.
Yeah. Now, this may seem like a stupid question. I'll apologize up front, but how much of the business for a company like Burst is around making sure companies can store as much as they possibly want and use it versus being able to make sure that the customer can be more efficient with how they identify and selectively manipulate data and or save it, because it's even for the average peruser of edge opportunity, it's really easy to say, yeah, I've got a smart building and it collects 20 gigabytes worth of data a day. And if I do some time series analysis on that data, maybe 5% of it is worth keeping for trend analysis, and another 5% of it is used real time to make sure the elevators are in the right place and that the air conditioning is doing the right thing and the doors are on or the lights are on or whatever the case may be, right? So where do you see the position of being able to manage that data more effectively for the consumer? Because I mean, if it can get out of control in the cloud, it seems like it's a problem that needs to be fixed first at the edge. Right?
It absolutely is. Yeah, I mean, depending on the data change rates and creation rates, I mean, as an example, we've got customers with factories, remote factories we talked about, that generate between 0.5 terabyte and 2 terabytes of new data a week.
Yeah.
So it doesn't take very long, to overrun, the local storage. And so they've said things like, well, most of that data is just falling on the factory floor today. What they really want in that case is to take not all of the data, but certain data, push it up into the central data center or public cloud, where they can create what they call a single source of truth. Okay, that they can then come back and maybe put in data warehouse, or eventually they'll archive it, but it kind of goes through that data use cycle and it gets distilled down to the point then eventually gets archived. But I think that's one of the big challenges, as always with data, is how do you tier the data or manage the data between different cost silos, because you can't afford to keep everything on SSD, right? So you've got to have some strategy at the edge as well, whether that's pushing the data you want to archive up into the cloud, maybe for cheap object storage, because you don't really expect to access it again. You have to have it maybe for regulatory compliance or posterity reasons. But then you got to have some amount of the data out at the edge. So I think part of the critical question is, how much storage do you foresee that you're going to need? And then what's your data strategy at the edge? What's the data creation rate? And then how much can you distill that down? And then can you really send that you want to keep up to the central location and get it out of there? Otherwise, I mean, you're going to overrun your local storage at some point pretty quick usually.
This is a really off the wall question, and feel free to say, Mark, I have no freaking clue. And I'm perfectly okay with that, because I don't know that anybody has an answer to this question, and it may not even be a worthy question. But as a longtime builder of infrastructure, one of the reasons why people centralized was because adding one more disk drive to 1,000 is one thing. Adding one more disk drive to where you only have room for 10 to begin with is a whole different story, right? You may not have power. You may not have easy access. There's all those things. How are there methodologies that you've seen effective with some of your customers, some of the, the data management experience you guys have, that actually allows them to quickly assess whether there's a return on investment for just continuing to expand the data they're collecting, versus sticking to the original assumed business plan, right? And you're a business owner. You're a CEO of your own company. You know very well. I assume that you do, or agree with my assumption, that most business plans are a great line in the sand, but if you can't be flexible with them, then you've got problems. And so if I build something that says, well, my data collection occurs over a 30-day period, I'm assuming that I'll keep 10% of that data on an ongoing basis, so prorated over the course of the year. If I'm collecting 10 terabytes a month, I need to plan for a growth at the end of the year of 45 terabytes, whatever the number works out to, right? What have you seen people do, or what have you guys been able to do to help people financial model what, extending the original business plan when they've discovered that maybe there's new opportunity to store even more data? Because I mean, everybody believes, even when it's not true, everybody believes the more data, the better, And we all know that well, some of us know that that's not necessarily true. But again, I apologize. I'm overcomplicating the question, but I hope that makes sense.
That's okay. It reminds me of the old adage that no plan ever survives first contact with the market, right? And
Right.
I know that's always been the case for every plan I've created, but yeah, the data problem, I think it depends a lot on what you're planning to do. If you have enough insight as to what you think you want to do with the data. As an example, gosh, as far back as the 1980s, when I worked in the process control industry, we had the same problem. We generated massive amounts of data from all these sensors,
Yep.
and yet they knew they wanted trend data and historical analysis of the different probes and temperatures, pressures, what have you. So what we did back then is we would basically distill the data streams down into hourly averages, daily averages, and min-max standard deviation. And so we statistically compress it effectively, right? And then you could kind of see you didn't need every little data point if you had the min-max and the average. Right. Standard deviation, you could essentially get to the answer you were probably after, and it drastically reduced the amount of data stored. So I'm thinking something like that is a good strategy at the edge. If you can't, I mean, it's just impractical to keep every data sample.
Right.
It's just not even affordable, or it's not a sane strategy, really. Yeah. Right. So I think it depends on what granularity of the data you really need, or you're willing to live with. And I think that's a huge, cost trade-off that has to be made pretty early on in the design. And so you're either going to keep the raw data, or you're going to process the data to the point that you don't need the raw data, but the summarized data, if you will, is still useful to you.
Yeah. No, that makes a lot of sense. Well,
and I don't know if that's the right answer, but that's
I think so. I mean, I think it is the right answer. I'm always looking for somebody who somehow has magically solved the world's problems, and I just didn't know it. And so they tell me, and there isn't an easy answer. I think your answer is perfectly accurate. And the reason I asked it is because I'm always looking for the kind of the 80-20 rule, right? And if I can build an environment for data collection to begin with, I've already made one of the biggest expenses. Right, that's the biggest expensive is creating it, deploying it, buying it, and deploying it. After that, it's if I grow by 5% or 10%, what's the cost of that growth and that accretive management overhead versus the assumed value of keeping that much more data? And I realize that Mark's in dreamland, and every single data environment is going to be a little bit different, and every single megabyte of data saved is going to have more or less value depending on that environment. But I guess as a longtime infrastructure geek, I'm always looking for somebody who might have created a smart tool for helping to gauge that return on investment and determine a methodology for affecting it. Because one thing that we've obviously agreed on already during the course of this discussion is that edge will need to be managed a lot different than how centralized compute has historically been managed. And that's at all layers. That's from how it gets distributed to how it gets supported to how the information collected gets leveraged, et cetera, et cetera. So anyway, that's why I'm asking. I know there's no perfect answer.
Well, I think there's a balancing act that one has to sort of come to grips with between how much data you're going to store locally, the granularity of it, how much you can afford to toss because it's really not useful. It's not going to be, likely to be derived value. There's regulatory compliance issues. How much of it are you allowed to filter or summarize or, average out? Some cases, like for e-discovery, I mean, the whole point is get all their raw data, for a legal case. So you can't summarize anything. Right. So I think it depends a lot on the use case, but like everything, there's some kind of right balance between local and centralized. And I think drawing those lines and kind of quantify, at least initially, with some headroom for maybe however far out people can plan these days, 3 years, maybe, if they're lucky. That's probably about as good as it's going to get, I would think, these days.
Yeah, no, I would agree. So, unfortunately, we're already coming close to the end of the half an hour,
Okay.
Rick, and I have thought of a lot more questions than we've accommodated. But there was one question that we both wanted to make sure we touch on before we wrap up, and that's about open source NIFI project. Talk a little bit about that. Why is that important?
Yeah, we're talking about Apache NIFI, which
Yep.
stands for Niagara Files. It's interesting. The NSA actually open sourced NIFI years ago. Most people don't know this, but it was developed to solve sort of the Tower of Babel problem the U.S. government had post 9/11, where they realized none of their systems could talk to each other. They had all these massive silos, and none of the agencies or the systems were mostly incompatible. So they built NIFI to solve this integration problem on a massive scale. And then eventually, I think they invested more than $100 million, taxpayer dollars, and they open sourced the 4th generation of NIFI. And NIFI is a mature, very robust data flow engine that's got a visual drag and drop editor that lets you configure your data flows visually. And one of the things that it does that's different than some of the other data pipelines is it's got what they call provenance, the ability to track every piece of data that is ingested into the system, every step and transform it goes through, and then where it goes, because obviously they need a chain of custody of that data or the ability to go back and audit. So it turns out that's actually a very valuable capability for business as well, because we're all getting hit with the need to do auditing and compliance now. So, but yeah, we decided that when I discovered NIFI pretty early on, I think it was 2015, and we started working with it that far back, and eventually, productized some things around it, and it's been a great technology platform to build upon.
I was just going to say, I wanted to clarify that, and you guys actually built your solution, the burst solution, on top of NIFI, right?
We started with NIFI, and we're adding things like Apache Kafka and other things that I talk about in my CTO video on the website. But yeah, it's we like to leverage open source and not recreate the wheel where we can. There's so much value already out there. But obviously customers expect something that's a supported infrastructure, and then they always want something different than what you get off the shelf. And open source is great, but it can be difficult to support in an enterprise environment. So we like to take it, and we're doing things like making it containerized and making it scalable with Kubernetes, things like that make it really useful in the real world, for real projects.
Awesome. Well, I'd be remiss if somebody mentioned Kafka to me and I didn't mention my my ex-boss and good friend Derek Collison's company, Cinedia. So if you haven't looked at their messaging platform, you should take a look. Amazing.
Awesome.
Anyway, even though I just did try to sell his company, I'm not here trying to sell his company. It was just an interesting opportunity. But Rick, this has been really fascinating, and I think if you're open to it, we may want to find a more even more focused data discussion about Edge sometime in the next few months, because I'd like to dive into this a little bit more, because I am by no means an expert on how much will be created and what that creation will push in the way of industry change and application change and support change, et cetera. And I think it is by most even less understood than it is by me, which is not good. That this is an enormous area of opportunity to help people not stub their toes, but also to help see where the opportunity is. So
totally agree with that. We're not experts either yet, but we're learning, and we're learning a lot from our customers, which is the best way to learn, I think.
So in the spirit of that, give us the 30-second pitch. Why would somebody call Burst in the first place?
Well, on the Edge side, I think we have the most flexible edge and off cloud to cloud data platform available today. And it's the most flexible and the most extensible. And, part of that's because we started with NIFI, but yeah, we see connecting the off cloud world with the on cloud world is a huge multi-billion-dollar opportunity over the next, say, 5 to 7 years. So we're focused on that. I mean, there's a lot of other things people are doing with Edge and with cloud, but we're pretty narrowly focused on that corridor and solving the problems that
Awesome.
are entailed there.
I think you've planted yourself in a pretty good place, even if you did start early, as you said. I think you've planted yourself in a pretty good place. So fantastic.
Excellent.
So Rick, where can people find you if they want to follow you or keep an eye on what's going on?
Sure. You can go to our website, www.burst, B-U-U-R-S-T. That's 2 U's, and burst.com.
Awesome. Well, Rick, thank you again. I really appreciate you being on. This was fascinating, and I look forward to continuing the conversation.
Thank you for listening to the Edgevana Podcast. Be sure to subscribe to the show on your favorite podcast listening app or on YouTube. To learn more, visit www.edgevana.com. Thanks for listening, and be sure to join us on our next episode.